Welcome back, everyone. Last time we were digging into Tkinter Treeview, right? We got it to display our MySQL records, insert new ones, even delete them.
Really handy stuff to have in your toolkit.
Absolutely.
Yeah.
But today, we're leveling up, taking our Treeview skills even further. We're tackling a problem that can be, well, a bit of a headache.
A headache.
Yeah. When you're working with data sources where you don't know in advance how many columns you're going to have.
I see what you mean. In a perfect world, you'd always know exactly what your data looks like. But in real-world projects, it's rarely that straightforward.
Exactly. It's like one day you're pulling just the ID and name from a student database, simple SQL query, select EAD, name from students,
Right.
and the next day, bam, you need every single column, full select date. So how do we build a tree view that can handle that kind of flexibility without having to rewrite our code every time the data changes?
Yeah, hard coding each column every time your query changes, that would be a nightmare, wouldn't it?
Total nightmare. So what's the solution?
Well, that's where Python's lists come in. They're surprisingly powerful in this situation.
Okay, lists. We use them all the time in Python, but how do they help us with Tkinter Treeview?
Think of it this way. We can use a list to store the names of our columns, right?
Okay, yeah, that makes sense.
And the great thing is we can grab those names directly from our data source. It doesn't matter if it's a database, an Excel file, a CSV, whatever.
So instead of us, the programmers, having to define the columns in the code.
Exactly. We extract them straight from the data itself.
Smart. So we're basically giving the tree view a set of instructions that, adapt based on the data it's given.
Precisely. And the tutorial goes even further, showing how to do this with a bunch of different data sources. It's a real data source extravaganza.
I was going to say, MySQL, Squalite, Pandas data frames, even Excel and CSV files. Very cool.
It really highlights how flexible this technique is.
It does. Okay, so can we break down how this actually works, step by step? For example, let's start with MySQL.
Sure. So for MySQL, you'd use Squalchemy to connect to your database, right? You execute your query. And then you can neatly grab both the column headers and the row data from the result.
Okay, makes sense. And what about Squalite? Is that similar?
Very similar. You're still using Squalchemy to handle the connection and the query. Once you understand the core concept, you can apply it to pretty much any relational database.
That's great because, relational databases are still so widely used. But what about something like Pandas data frames? I feel like they're becoming more and more popular, especially for data analysis.
Absolutely. And the tutorial shows how you can easily convert a data frame into, well, a list of lists, which is exactly what we need for the tree view.
Okay, so even Pandas fits into this approach.
It does. And you can even grab those column names directly from the data frame using a simple list, df.
Simple and elegant.
Exactly. Then we've got Excel files, which we can handle using the OpenPixel library. The code walks you through opening the file, iterating through the rows, extracting the values.
I was looking at that part. It's got that neat trick where it grabs the first row and uses it as the headers. Saves a lot of time.
Right. No need to define them separately. And finally, we've got CSV files.
I was going to say, Python makes working with CSVs so easy, doesn't it?
It really does. The CSV.reader object lets you easily go through each row. And just like with the Excel example, we can snag that first row for our headers.
So smart. Okay, so now we've got all this wonderful data, all nicely organized into lists. But now comes the fun part, actually building the tree view with it.
Right. First, we create a tree view object in Tkinter, the usual stuff. But then remember that list of column names we created earlier. That's where the magic happens. We use that list to essentially tell our tree view, hey, these are your headers, and these are the columns you need to create.
So we're dynamically defining the entire structure of the tree view based on this data. That's amazing.
It is. We use a loop to go through that list of column names. For each name, we use trv.column.
trv.column.
Yeah, that function lets us configure each column. We can control the width, the alignment, all sorts of things.
So we're not just creating the columns, we're styling them too.
Exactly. And then to set the header text for each column, we use trv.heading.
Okay, trv.heading. Got it.
Yeah.
So in just a few lines of code, we're building the whole tree view structure. Row by row, header by header, all based on our data.
It's quite powerful. And now we have this perfectly structured tree view ready to be filled with our data.
Okay, I have to ask, how do we get the data in there? What's the secret sauce?
The secret sauce is actually pretty straightforward. You remember that source set variable, the one holding all our row data?
Yeah.
We loop through each row in that set, convert it to a list, and then use trv.insert.
Trv.insert sounds important.
It is. That's the function that takes our data and puts it into the visual structure of the tree view. We tell it where to insert the row, usually at the end, and then the crucial part, the aid.
The aid.
The aid, it stands for item identifier, basically a unique ID for each row.
So like each row gets its own little ID card.
Exactly. We need that ID if we want to do things like update or delete specific rows later on.
Gotcha. And then we also give it the actual values for that row, right?
Exactly. A list of values in the same order as the columns we defined earlier.
It's all starting to click now. So we dynamically built the structure and then used trv.insert to like seamlessly fill it with the data.
Precisely. And there's one more cool trick. Controlling how much of the data is shown.
Oh, tell me more.
We can use the Treeview attribute to limit how many rows are displayed at once.
That's really smart for user experience, especially if you've got a huge data set. Nobody wants to be bombarded with a wall of text, right?
Right.
We can just show a nice, manageable chunk of data at a time. Love it.
It's just a taste of what you can do with Treeview customization. There's so much more to explore, but we'll save that for another deep dive.
You know what? I'm already looking forward to it.
It really is amazing how we can create a tree view that adapts, instead of us having to constantly tweak the code every time the data changes.
It's like we've given it superpowers or something. It really shows how powerful Python is for working with data, not just processing it, but displaying it too. I remember when I first started learning Tkinter, I was so intimidated by anything that involved making the interface dynamic.
It can seem daunting, yeah.
But this approach makes it feel so much simpler.
And what's really impressive is how it doesn't care where the data comes from. Database, spreadsheet, even just a plain text file.
Mm-hmm.
The logic is the same.
That's so important, right? Because nowadays, data comes from everywhere. Okay, but for our listener who might be thinking, this all sounds very technical, but how would I actually use this? Can you give us some real-world examples?
Sure. Let's say you're building a dashboard for your business to track all those key metrics, right?
Okay, yeah, a dashboard.
And your data is coming from all over the place. Sales figures from a database, marketing numbers from a spreadsheet, maybe website traffic from some API.
Lots of different sources, yeah.
Exactly. And with this dynamic tree view, your dashboard can handle all of that. It can adapt as you add new data sources or change what you're tracking.
So instead of having to constantly rebuild the dashboard every time something changes.
You've got this flexible system that can evolve along with your needs. Saves a ton of development time.
And I bet leads to a way better experience for the people actually using the dashboard.
Absolutely. Can you imagine if the dashboard kept breaking or needing manual updates all the time? How frustrating would that be?
Super frustrating. You want tools that help you, not slow you down.
Yeah.
Another thing I really liked about this approach was the efficiency. We're basically automating a process that would be a huge pain to do by hand.
Oh, yeah, for sure. Think about the column headers, for example. Instead of hard-coding them for every possible data structure, we just grab that first row of data, boom, done.
So simple, but brilliant. And then, using loops to dynamically create all the columns and populate the tree view, that's automation at its finest.
Loops are a lifesaver in these situations. Imagine having to manually create a new column in the tree view for each column in your data. Ugh, no thanks.
Talk about tedious. And error-prone, too.
Exactly. The more we can automate, the less chance there is for human error to sneak in. And that means more reliable, robust code.
Which ultimately means a better experience for the end user. They get an application that just works, smoothly, reliably. What's exciting is that these ideas go beyond just tick and tree view, right?
Oh, absolutely. Using lists to dynamically build your interface, automating tasks with loops, adapting to different data sources, these are core programming principles.
You can use them in so many different contexts.
Web development, data visualization, command line tools, you name it.
That's what I love about deep dives like this. You learn something specific, but you also gain these broader insights that you can apply anywhere.
Speaking of broader insights, we should probably talk about what happens when we've got a ton of data to display, right?
Oh, yeah. We've covered how to build this dynamic tree view, how to fill it with data from all sorts of places. But what if we've got hundreds, even thousands of rows? Displaying all that at once would be pretty overwhelming for the user.
It would be information overload. That's where pagination comes in.
Pagination. Breaking down large data sets into smaller, more manageable chunks.
Exactly. Makes it much easier to navigate and understand the data.
And lucky for our listeners, that's exactly what we'll be diving into in the next episode. We'll explore how pagination works, why it's so important, and how to implement it in Tkinter to make our tree view even more user-friendly.
It's going to be a fun one.
We've really covered a lot of ground in this deep dive.
Yeah.
We started off talking about building Tkinter tree views that can handle just about any data source you throw at them, and I think we found some really elegant solutions.
Yeah, we did. We saw how we can leverage Python's list to grab the column names right from our data. Doesn't matter if it's SQL, CSV, Excel, even those fancy pandas data frames.
And we didn't stop there. We learned how to use those column names to basically tell our tree view how to build itself, creating those headers and columns dynamically.
On the fly.
Exactly.
Yeah.
And then we got into actually putting the data into the tree view using that trv.insert function, making sure each row gets its own little ID so we can refer to it later, which I'm guessing will be super helpful when we start getting into more advanced features and future deep dives.
Absolutely. It's all about laying a strong foundation. And once you have that, the possibilities with Tkinter Treeview are almost endless. You can style it, you can control how much data is visible, you can even add things like sorting and filtering.
It's really impressive how much power Tkinter gives you for creating these dynamic interfaces. And I think what really stood out to me was how this approach is all about being flexible, data-driven. No more rigid, hard-coded solutions.
Yeah. In the real world, data is always changing, evolving. We need tools that can keep up with that.
Right. And this approach gives us just that. Applications that are not only robust, but can adapt to new data, new structures, without breaking a sweat.
Exactly.
That kind of adaptability is going to be so valuable for anyone building applications that work with a variety of data, dashboards, analysis tools, anything that displays structured data. This dynamic tree view approach is a real game changer.
It really is. It puts the focus on the data, allowing developers to build applications that respond to, well, the ever-changing information landscape.
Perfectly said. And speaking of handling lots of data, remember earlier when we touched on the idea of pagination?
Ah, yes, pagination.
Well, that, my friends, is going to be the focus of our next deep dive. We'll be taking a close look at how pagination works, why it's so crucial for good user experience, especially when you've got tons of data to display.
Because nobody wants to scroll through a million rows.
Exactly. We'll explore how to implement it in Tkinter so that our tree view is not only powerful and flexible, but also super user-friendly.
It's going to be a good one.
It is. So if you want to learn how to make your Tkinter tree views even more awesome, make sure you hit that subscribe button and join us for the next episode. We'll be back soon with more deep dives into the fascinating world of programming. Until then, happy coding, everyone.